And so mean absolute deviation is one way to describe the blank or how the spread how spread out a data set is. Any guesses? Variance, sorry. Variability. Variability. Okay, variability, or how spread out data set is. By using the mean absolute deviation mean absolute deviation is the average distance. The average distance that data points in a set of data are from the mean. Okay, so that's a mouthful. But what I want to do is show you that it can be really 3 easy steps. It seems like a lot, but it's 3 simple steps. So what does deviation mean? What is deviation? To like separate or to go to be away from like the like if I'm on a road, I'm driving down the road and I deviate in my direction, I've turned off the road and I'm going down a different way. Okay? So if I was going down a road and I deviated, it would go over here. So what we're asking is how far away is that deviation? How far away is it? Okay? And so in order to find the average, so say we had a bunch of people that went down this road, but a lot of them got lost, and they ended up on these paths. We want to know what's the average distance away from the mean, this middle value, what's the average distance away that all these people were. So that's what we're trying to find. So first thing we have to do is find the mean of the data set. Now, on the board to the left, I've defined that. But does anyone know what a mean is? How do I find the mean?
Add it all up and then divide it by how many numbers there are.
Good. So for the mean, we add everything together and then divide by the number of items. Okay? So add it all divided by total. Let me make that a little smaller. Total items. Okay, so add it all up, and then divide by the total number of items. Okay, that's what the mean is. Step 2 is find the distance from each point. And when we do the example in a second, I'll show you. Okay? So find the distance from each point. Well, distance is always what? Can you say that I live negative 50 miles from my grandmother? It's always positive, okay? Distance is always positive. Even if we get a negative value when we subtract, we're going to say, hey, I understand it's negative, but it's distance, so I'm going to make it a positive value. And lastly, we just find the mean again with the new numbers. So, like I said, 3 simple steps, but a lot of things can happen in these bottom 2 steps. Okay, so let's look at an example. So let's find the mean of the data first. So what do I need to do with all these values? Add them up. So with the calculator, you can start adding. I'm just going to write out what it is that you are adding. plus 67, plus 70, plus 62, plus 64. Now, in the calculator, when you hit enter, you'll get an answer from that, and then all you have to do is divide by 1, 2, 3, 4, 5, 6, 7.
I know the answer, Mr. Hill.
All of them added together, or
Oh,
both?
Wait, no.
No, what did you get total then?
Wait, total of all of these numbers added?
Yeah.
Is your name Rich?
455.
I'm sorry?
455.
So 455, and then divide that by 7, and what did you get? 65. Okay, so in the corner here, I didn't have a ton of room, but these are the two same. The red and the black are the same thing, right?
I got 400.142856.
I don't think that you. What happened is whenever you divided, you didn't put all your addition in parentheses, so you divided the last number by 7 and added it to all the other numbers.
Oh.
Okay, so if you're gonna do this in the calculator in one step, you need parentheses around that whole top part. You need to put parentheses at the beginning and the end. Okay, now here's the next step. Let's see, 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7. So I'm going to put a box for each of those numbers. And in the top box, I'm going to write the mean. What did we say the mean was? What did we find the mean? 65. So I'm going to take 65 and subtract the first one. What was the first one? 61, right? So what is 65 minus 61?
4.
So in the bottom box, I'm going to put that value, 4. I'm taking this number up here and subtracting 65. Okay, what's the second number? Okay, so 65 minus 68.
-3.
-3, but this is a what? It's a distance, so we're going to make it a positive. Okay, because distance is really how far is it from here to here? How far is 65 to 68? 3. How far is 65 to 61? 4. So it's a question of how far. The next one is what? 65 minus 63, what do you get? 2. 65 minus 67. -2, but it's a distance, so it's positive. Next one is 70, so 65 minus 70 is -5, but it's a distance, so, and then the last two, 65 minus 62, 1, 2, 3, 65 minus 64 is 1. Okay. Is everyone okay with what we just did? We just took the thing we found, the mean, and took it away from all of them. Is that okay? Now, like I said, this is a process, right? There's a lot of steps. Okay, so in this next box, we're just going to average those values. That's it. We're just going to average those values. So, let's do this in blue. 4 plus 3 plus 2 plus 2 plus 5 plus 3 plus 1, all divided by 7. So remember, in the calculator, if you're going to put this whole thing in the calculator, you need parentheses around the top. Yes, sir.
You want the total of the top one or all together?
You can give me all together this time.
2.85.
No.
Yeah. don't put every single decimal.
2.8.
57142.
Ah, so if it's 2.857, it's really 2.86. Remember, we have to round if we're going to round. 2.86.
Oh, yeah.
Okay? Now, what does this mean? What is this giving us? A police officer recorded speeds. So these are speeds. These are how fast people go. And so this means that on average, people people's speed is 2.86 miles per hour away from 65. So in other words, you would expect most people to be 2.86 miles per hour away from 65. Okay, on average, people's speed is that far away from 65. So what are we really looking at? We're looking at how far away from what?
65.
But what is 65? It's the what? The mean. So mean absolute deviation is really an average of how far away from the mean. Okay, let's do number 2. So add these things up. Add those things up on the next one. Add them up. So these are ages of patients in a waiting room at a doctor's office. So plus 11, plus 28, plus 64. Real quick, 1, 2, 3, 4, 5, 6. Would you think that ages of a doctor's office are going to be more or less distance away from the mean? From the previous problem, do you think it's going to be a bigger or a smaller number?
I'm gonna get bigger.
Bigger. And we'll talk about why in just a second. Okay, what is that value? Anybody got it?
33.
So you added them all up and divided by 6 and you got 33? Okay. Same thing again. I'm going to create a box, maybe a better box than that. And then I'm going to take 33 minus 4. (33 minus 33). 33 minus 58. 33 minus 11. And once again, you can do this in the calculator as well. 33 minus 28. And then the last one, 33 minus 64. Okay? At the top right there.
Oh, I just did a box in the wrong.
It's okay. It's not a big deal. What's 33 minus 4? Okay, 29. 33 minus 33, that's a tough one. 0. 33 minus 58.
25. Honestly.
Negative 25, but we're dealing with distance. 33 minus 11.
22.
33 minus 28.
5. 5.
And lastly, 33 minus 64.
Negative 31.
But it's a positive because of distance. Okay, now, what do I do in letter C? What do I do?
Add them all up.
I add those new numbers up and divide by 6 again. So, 29 plus 0 plus 25 plus 22 plus 5 plus 31.
112.
Okay, and then we have to divide that by 6 again. 18.6 repeating.
There's a 7 at the end.
Correct, which is why it's repeating, because the calculator can only go so far. Okay, so we want to explain the situation. Okay, and so this means the average age in the doctor's office, the average distance average distance in age from the mean, which was what, 33, from the mean 33, is 18.6 repeating.
Uh-oh.
Okay, so can somebody take 33 and subtract 18.6 for me?
I'll try.
15.4.
I think
Right.
14.
14.4, sorry.
14.4.
Yep.
And then 33 plus 18.6 is 51.6. Okay, so the reason I bring this to your attention, what I did is I took this value and I added and subtracted it to the mean. So the whole point of this is to say, if a random person walks into the doctor's office, most likely, they're going to be between these two ages. Okay? So that's why this is useful. This is useful because we can say, most likely, because of this being 18.6 away from that, being 18.6 away from 33, that if we took it away and added it to 33, a random patient that walked in maybe be 25, because it's between the two. It could be 17, because that's between the two. Now, you're going to get some people out here, like the 4-year-old, right, or the 72-year-old, right? You're going to get some people outside of those, but most people will fall in between those two. And that's what this is for. Okay? I want you to try number 3 on your own.
So tired.
I'm sorry. Okay, can someone give me the mean?
32.
32. Okay. Are those the same numbers that y'all got? 11, 6, 15, 12, 10?
Yes, sir.
Okay. 11 plus 6 What'd you get when you added them all up and divided by 5? Hmm?
10.8. 20 divided by 5.
That looks like 17.8.
Yes.
Yeah.
I just write.
Yeah.
I just have bad handwriting.
So, okay, bad handwriting equals bad doing.
Hey.
No, I mean, look at my handwriting. But I just, if it looks like a different number, it's going to be counted as a different number, so just be careful. Okay, the average time it took in minutes to get to work was between what and what? So what can I do with these two values to give me a between? I can take 32 minus 10.8. What's 32 minus 10.8?
32 minus
21.2.
Okay, and then 32 plus 10.8 would be 42.8. Okay, so you would expect whoever this is to get to work in between 21 minutes and 43 minutes. So somewhere between 21 and 43 minutes is about how long it will take for this person to get to work. Do all of the numbers fall between those? Almost.
No.
That very first one is just outside, and then these two,
47.
those two are just outside. But in general, this is an average of distance. So, you're going to expect that most of the time it would take between those two values to get to work. Okay? So that's what this is doing. This is creating a range, a low value and a high value that you can see most of the data is between. Okay? So